Yep, nothing can go wrong here. This operation's gonna go great. Can't possibly be doing anything wrong here. Yep, this is gonna be perfect. Just set this up, it's gonna go perfect. Hello Internet, my name is Quinn and this is Blondihacks. The other day my friend Rex hits me up and says, "Hey Quinn, I'm making a turning saw for woodworking and I've designed a new kind of pin that holds the blade. Can you help me prototype these things?" And I said, absolutely. Now you're thinking, woodworking on Blondihacks. I've thrown a lot of shade at them over the years, but Rex's channel is different. It's all hand tools. And if I was ever going to be a carbohydrate foamer, I think it'd be hand tools because I find it really beautiful and amazing what they do. So let's help Rex out with these pins. This is a turning saw pin or bow saw pin. Woodworkers often buy these because it's the only metal part required to make one of these saws, and so it's a common woodworking project. Really my problem with woodworking is the power woodworking tools. Machine tools are stately and civilized, whereas woodworking tools are screaming banshees of dust and death, and I really find them unpleasant to use. Anyway, more to the point, here's the pins that Rex has designed, so let's get into it. Got this piece of 12L14 steel here, which I think will do nicely, so I will cut a length off sufficient for 2 of these pins, because, well, you need 2 for one of these bow saws or turning saws. The portable bandsaw makes short work of that, and it's over to the lathe. I'll start by facing this off, as is tradition. Now, I had just done a regrind on this tool, so you can see I've got a little nubbin there. It wasn't quite on center, so I'll take this opportunity to adjust that a little bit. Facing off a part is a really easy way to see if your tool height is correct or not. And if that nubbin faces off, then we're good to go. We're going to need plenty of tail support for these long, thin parts, so I'm going to put a center in the end here with my number 2 center drill. Now the goal there is I'm trying to put in the smallest center that I think I can get away with because this is going to be a small diameter part and I don't want to eat up the entire end of the part with the center if I can help it. So now I can pull the stock out to length and I'll measure how much I need plus room for the parting blade, just a rough estimate, and I'll put a little witness mark right there. Now most of this stock is going to get turned away because we're making small diameter parts out of this, but the largest diameter of the pins, the center boss, is only a little bit smaller than this stock. So I'm turning the whole bar down to that largest diameter, and then I'm going to mark where one shoulder of that large diameter disc in the middle is, and then I'm going to turn down this end all the way down. I'm making a lot of chips on this project, but it will make the pins a lot stronger if they're all one piece, so I think it's worth doing this. This freshly reground tool is doing great. This is a 100 thou pass, 50 thou depth of cut, which in steel is quite a lot for this little lathe. Once I get down to a small diameter though, I run out of room for that tool, so it's time to bring in the little guns. I've got this special tool for this situation. It's got a 55-degree angle ground on the back of it, so it'll clear the 60-degree center, and I can get in there real close and finish up this job. I'm going to put just the tiniest little bit of a chamfer on there, just enough to break that corner, doesn't need much. And then I'm going to put a generous chamfer on the other end, as generous as I can get away with. I have to get in real close to the center there, and you can see how I did that. Basically, I was looking straight down on the top of the tool as I did that, and as long as I can see light between the end of the tool and the spinning live center, I know I haven't damaged anything. Now I'm going to mark the final length of the part here, sort of pessimistically. I'm going to leave this generous. And I just realized I forgot to face off this disc here in the middle. I was taking heavy cuts, and so I wasn't able to come up to the same point every time on the dial indicator there, so that needed squaring up. I had left a little bit of a dome in there. Now we can part this thing off. Whoa, come on, Super Chip. Hang in there, you can do it. You can do it. Super Chip for the win. Oh. And Yahtzee. Now we can face off that rough end again, put a new center in it, and then activate the bar feeder And we have stock for number 2, and we make the second part with all the same steps. Now then, time to get rid of the 3-jaw and bring in my new toy. This is the eBay junk bin collet chuck that I made in a recent video. It's going to be the perfect thing for the rest of this job. Little sidebar while I set this up. When I made this collet chuck, a few people suggested I should try different positions and look for the one with the lowest runout. So I did that, and I marked it with a 0 there because my chuck mounting ring has a 0 on it as well for the 3-jaw. As it turns out, in the original video, I got lucky and actually hit the lowest runout spot. So yeah, that's as good as it gets. So I'm going to start with a larger collet so I can hold the large end here, the stock, and I'm just going to push it all the way in and face off the end there to get rid of the parting nubbin and make sure it's all nice and square. And now what I can do is pull it out again and measure the overall length of the part, because remember it was roughly parted pessimistically there. I show this because I think a lot of beginning machinists underappreciate the importance of indicators in machine tool setup. You know, a lot of people think that you can use the hand wheels to a certain point, but anything more than that, you got to have a DRO. But indicators really can do everything that you need. A DRO is just a more convenient form of setting up indicators for all of your carriage moves. So don't forget that. Anytime you want to move a slide on a machine a very specific amount and you don't want to worry about backlash or imprecision caused by coarse markings or whatever, set up an indicator. That's what they're for. I'm aiming for 2625, and well, look at that. If it's good enough for the guesstimators, it's good enough for me. The cool thing about the collet chuck is I can swap out to a 1/4-inch collet, flip the part around, still maintain pretty good concentricity, and I can work on the other end here. Just put my center back in there, and we are good to go. We can turn the other end. So I turn this down also to that small 1/4-inch diameter, and I leave that big disc in the middle there. If I didn't have the collet chuck, I'd be doing all this with the 4-jaw, and there'd be a lot more dialing things in, and so this is just very convenient, I have to say. Once that's roughed in, then I just face the end of that disc there to the proper size, and then I just clean up that inside radius there. And once again, chamfer that end, hopefully without gouging up my live center. This end is going to be threaded, so I'm going to put a little thread and groove in there with this half-round tool. This is going to do a bunch of things for us. It's going to make a nice curved profile in there, which is stronger than right angles. It's also going to provide clearance so that this disc will thread snugly up against the wooden handle, and it gives us a starting point for the threading tool in there. There's the blank for one of the pins. I made a second one the same way, and we are done with the lathe for the moment. We got to go over to the mill while we still have solid diameters here that I can use to put in the collet block. And I'm going to set up to drill some cross holes. So I need a little machinist jack for support there, and I'm going to find the center line of our cylinder, and I'm also going to need the end. Then I'm very carefully center drilling some teeny tiny little spots here at the top just so that the drill doesn't wander off. And then I'm pre-drilling a little bit smaller than 1/16, which is the reamer that I'm going to run through here. It's a very, very tiny reamer, and thus a very, very tiny pilot hole. I'm drilling 2 holes here. One is just a cross hole that's needed by the design, and the other one is going to be the end point of the angled slot that holds the turning saw blade. That'll make more sense here in a minute, but here goes the teeny tiny reamer. This is the smallest reamer I own. This is a 1/16 reamer. Next comes the feature I'm most nervous about. I need a very thin, very deep slot right down the center of this thing. So to find the center line, first of all, I'm using a feeler gauge above and below so that I have the same distance, and then I'm using the half function on the Z axis on the DRO. And then I'm going to get some oil on there, and I'm going to bring this slitting saw in. And the idea is I'm coming in from the side so that the forces are lengthwise along the collet, and that way I don't have to worry about not having any support here out on the end. The teeth are all running longitudinally as far as the collet is concerned. However, let me speed up the footage here so that you can see something that I couldn't see in real time because it was happening a lot slower. Did you see that? Yeah. Remember that time? Now I know you weren't there, but remember that time when I forgot to tighten the collet on this part and proceeded to try to run a slitting saw through it? Yeah. Well, I got away with it until I came around to the other side. I flipped the saw over and reversed the mill direction because I didn't have enough depth on that saw arbor, so I needed to come in from both sides. And well, in this direction, things got a whole lot worse. Scrap metal. So that was a bummer, But I put on my big girl pants and made the part again, and that gave me plenty of time to think about how I wanted to do this differently. So first and foremost, I tightened that collet block, and I also took the time to make a new slitting saw arbor here that has much better clearances, and tighten that collet block, make sure that's good and tight, yep. And this new slitting saw arbor will have its own video that I think, and I'll just tighten up that collet block again, that I think this new slitting saw arbor is really going to be the ticket here. You'll see how it gives me much better control, and the better clearances allow me to do a better job here, get the angles that I need to reduce vibration and the grabbiness of the saw, and tighten that collet block, and we are good to go. Let's try this again. Here on round 2, you can see how the better designed arbor, the increased clearance there, gives me lots of choices for angle of approach on the saw, which I did a lot of moving around here, because coming in from the side, it reduces vibration and chatter because the part is so poorly supported out here, but coming in from the end, the saw cuts better, it makes better chips. So I basically was able to find the sweet spot for each step here along the way. And when I got close to final depth, I didn't have quite enough depth here on the end of the saw, so I did have to go side to side a little bit on the arbor, which means there will be a little bit of a widow's peak in the bottom of that slot, but it's not going to hurt the function of it here, which is just to provide clearance for the saw blade. It was a relief to have that terrifying operation out of the way, and now I can move on to the other kind of funky slitting operation. For this, I'm going to need a little fixture. So I found this V-block in my scrap bin, and I machined one corner off of it there, and that will allow me to set it up at a 45-degree angle on the corner of the vise like this and hold the end of the pin here. And this will prevent excessive stick out here for this next slitting saw operation. I'm putting a 1/16 gauge pin through those holes, and it's a good fit because they were reamed, and then I can use an adjustable parallel on either side. Since the front and back of the vise are the same height, I can use this to make sure the part is correctly rotated in there. Now I need to figure out how far to come down with the saw, so I'm using a feeler again to find the top corner of the part there, and then I need to go down the correct amount. And to do this, a little bit of trigonometry was required, which I won't bore you with. You can see how helpful it is to have better clearance on the underside of the slitting saw arbor. That old arbor I had was always in the way, so this operation would never have worked. Now you can also just line up the slitting saw by eye with the side of the hole there, which honestly probably works just as well as all the math, but we are ready to go here. Now I was a little bit concerned about the slitting saw deflecting upwards because it's engaging with a sloped surface here, so I just kind of took very, very gentle cuts on first approach and just let the saw kind of make a flat spot before I go in too hard. Now luckily this is a pretty thick slitting saw, at least by hobby mill standards. This is a 1/16 saw, so it didn't seem to deflect really. It didn't seem to be much of a problem, but then I was able to work my way in there, and the setup was nice and rigid, so there was no trouble making good chips here. And because of that pre-drilled hole, I don't have to worry about how deep to go here. I just go until I break into the center line of the hole there. That was very easy, and that actually turned out great. With all those weird slots cut, I now have another fun, tricky thing to do, and that's cut the threads at the other end. And these need to be wood screw threads because they thread into a wooden handle, which I've never done before. So this is my model. This is a number 14 galvanized wood screw from a big box store, and I'm going to try to replicate that thread. So a little bit of inspection suggested that it's 11 threads per inch, give or take. So I set up a test piece just to see if I can cut that. So I set up the change gears for 11 threads per inch. I don't have a thread pitch gauge at that size, so I just measured a fixed number of threads and it looked correct. So I decided to see if I could cut this with a regular threading tool first, and just going into a depth that was sufficient to kind of close up the peaks and make them sharp. I've learned the hard way to always do a test piece for a new operation that you've never done before or you're not totally sure about, and I'm glad I did because this one took a couple of tries to get right. So this was my first attempt, and it looks sort of okay. I had to stop short of the thread peaks closing up because I was getting too deep. There was not enough material left in the center. So I drilled a pilot hole in a piece of wood and tried threading it in, and it did thread in, but I could tell that it wasn't cutting its own threads into the wood. It was just pushing the wood around. And you could see that it tore out a little bit of the top of the hole there, and I could tell that on a delicate turning saw handle it would probably split because it's not cutting its way in, it's just pushing. So this is not a proper wood screw thread, as you can see here. What needs to happen is I need flat landings between widely spaced sharp threads. Now, of course, commercial wood screw threads are rolled. They're not machined, but I'm going to try to machine them. So I've got a little jig here for my grinder rest that I use for this type of thing. So I'm going to grind precise 60-degree angles on both sides. And it's basically just a standard 60-degree thread cutting tool, but with the end blunted. So it'll create those little landings between the threads and allow me to create sharp threads without going too deep. So I did 2 more test pieces, and it took me a little while to get all of the dimensions dialed in, but the one on the right there is the sweet spot where everything kind of worked out just right. So that threaded right in there very well. It felt just like a wood screw going in. And then on inspection, you can see that it's cut itself some very nice threads in that wood there. I don't know what kind of wood this is. Dead trees all look the same to me, but it seems like a good wood screw thread. Now the end isn't pointed, so it's not fully self-tapping the way a regular wood screw is. So you need a little bit more of a generous pilot hole, but that'll be just fine for this application. So with the threading dimensions figured out, I can go back to the lathe now with the real parts, set them up here. I'm just using my fishtail to square up this new threading tool that we just ground, get my tail support in there, and we are ready to go. Now there's some run out, as you can see there on the part. I think there was something a little bit cockeyed in the collet there. Maybe there was a chip under it, but I did notice it, but it wasn't enough to really be a concern here for this operation, so I just let it go. And I did a little test, and the threads look like they are the correct pitch, so I went ahead and started cutting. And this was all pretty low drama. This 12L14 steel is very nice to cut. It didn't give me any trouble, even with the blunt thread cutting tool there, but I was using the compound, just like you're supposed to, at 30 degrees, just to minimize the cutting forces here, because this is a very deep thread. And again, the end of that thread cutting tool is blunt, kind of like an Acme thread, like a little tiny baby Acme thread, like Fisher-Price's My First Acme thread. As far as depth, I had determined experimentally with my test parts how deep to go, so I was just looking at my indicator, but you could also just blue it up and go until the peaks meet up and make a sharp edge so it'll cut into the wood. And I did go ahead and put a generous chamfer on the end there, even though it doesn't have a proper self-tapping point on it. At least putting a chamfer on there will make it easier to thread into the wood. Last step is to put some little wrench flats on there so you have a way to tighten it into the wood, and I wanted 50 thou of clearance there on the shoulder, so I've got a stack of feelers in there. And while I'm milling, it's singing like a tuning fork, so putting my finger on the end there quieted it down. And this was a pretty easy operation to get to the right depth and then use the magic indexing function of the collet block. I really like collet blocks, they're fun. And if I just match it up to the edge of the vise, same as it was, and I just go back down to the same number on the quill DRO, and those flats will be identical. And the wrench fits on there perfectly. So here you can see how the wrench flats are really key to be able to thread these pins into the wooden handles. There would be no good way to do it otherwise. So those are looking pretty good. I'm pretty pleased with how those turned out. But the real question is, do they work as turning saw pins? Hey Rex, give these a try for me, will ya? So here's Rex installing the pins. And that handle there, I believe, is some sort of plant-based substance. I'm not exactly sure how all this works, which I guess used to be like alive at some point. Wait, if parts of this are alive, does that mean you have to feed the saw after? I don't know. I'm going to stick with boiling rocks. And then the blade goes into the angled slot, like so. And you need 2 of these pins, of course, 1 on each side of the saw. And then the saw is tensioned in some fashion like this, hence bow saw. And here it is in action, and the power of this saw is it allows you to turn the handles as you cut and make very intricate curves and very fine cuts, which I guess is useful for tree jockeys. I don't know, I just work here. Well, these were really fun to make. I was surprised how challenging some of these operations were. I hope you enjoyed watching me make them. If you like what I'm doing, throw me a little love on Patreon, and I will see you next time.